Welcome back to this video of the KNX Security video series. In this video we take a look at KNX Data Security. So where is data security recommended and what are the three pillars of KNX Data Security? So first of all, the goal of KNX Data Security. The goal is to achieve complete security in the KNX system. It is recommended for a KNX twisted pair. Why? Because there might be parts of the KNX twisted pair line which are accessible from the outside. So where an attacker can hook up to the twisted pair line and then start to attack the KNX network. For KNX radio frequency, however, KNX Data Security is highly recommended. Why? Because on KNX radio frequency we have an open transmission medium. So everyone that can receive KNX RF telegrams can see them and may also can manipulate those KNX RF telegrams. Therefore, it is highly recommended to use KNX Data Security on the KNX RF side. But how does KNX Data Security works? Well, therefore we can take a look at the three pillars of KNX Data Security. So first of all, we have confidentiality, which prevents an attacker from reading the data being sent on the KNX network. Then we have data integrity, which prevents an attacker from manipulating a message. And last but not least, we also have freshness, which prevents telegrams from being used again. Let us take a look at an example for each of those pillars. So let us therefore start with the first pillar, confidentiality. Here we have a little example project with a push button sensor and a switching actuator. Without KNX Data Security, the push button sensor now will send its telegram onto the bus to the switching actuator, and an attacker which might connect to this twisted pair line is capable of reading out all of the informations being sent in this telegram. So it can see the group address, the value, the physical address, etc. However, with KNX Data Security, the telegram now is being locked. So we can't see any informations of this telegram. So when now an attacker is connected to the twisted pair line, it will only see zeros and ones. So the attacker can't read out the informations because encrypted values cannot be read. However, the switching actuator on the other side is capable of unlocking this message and will then react to this message. So this is confidentiality, which means that the messages will be encrypted. Next up we have data integrity. Now let us take a look at this example for data integrity. First of all, without KNX Data Secure. An attacker is going to hook up to the line so that it can read the messages being sent and then manipulate those messages being sent out. So here in this example, the push button sensor is being pressed. It sends the data telegram with the value on, and the attacker does a man-in-the-middle attack, so it means it will read the data telegram, manipulate the values, and instead now of sending the value on, it will send the value off, and the KNX switching actuator doesn't notice that at all and simply reacts to this telegram. However, with KNX Data Secure, this isn't possible any longer, because what we can now see is that in the telegram we also have the field MAC, which stands for Message Authentication Code. And this message authentication code is calculated by multiple values of the data telegram and the security keys. So whenever the push button sensor now sends a telegram, we now have this MAC field, and even if the attacker now is capable of manipulating the value, because remember that the first pillar also applies, so normally this data telegram is also being encrypted. But let us now take a look at this example where the attacker is changing the value to off and the MAC field isn't changed, and the switching actuator now notices that. So this new value doesn't fit to the message authentication code and therefore it is blocking this telegram. So now a man-in-the-middle attack isn't possible any longer. And now the last pillar, freshness. Here we can see that a message is being sent from the push button sensor to the switching actuator. The attacker might now see this message and then later on can resend this message. And this is something you can also try with the EDS6, because in the EDS you have the bus monitor, and inside of this bus monitor you can send telegrams with group addresses and values. As you can guess, with KNX Data Secure this isn't possible any longer, because we now also see here a second field, the so-called sequence number. And this sequence number is a counter which has to count up in order for the switching actuator to accept this telegram. So if we take a look here, the push button sensor sends its value with the sequence number 1. The attacker sees this telegram and resends it, but the sequence number hasn't changed, and so therefore the switching actuator notices that this is the exact same message, which just isn't possible, and so therefore it will block the telegram because the sequence number is not greater than the last value. So those were the 3 pillars of KNX Data Security. So confidentiality, which means encryption, data integrity, which means that we can't manipulate the values, and freshness means that we can't resend those values.